So this question, we have a graph, so we'll start right off with our friend Oizurga. So the origin, where is it? The origin is here, which means that this represents a y value of 0. So these are positive values and these are negative values, which we see over here on the scale like so. And so we found the origin. It does include the origin. This 0 goes with that 0. Y-axis is velocity, x-axis is time. The intercept, yes, at t equals 0, v equals 0. But we see there are a number of other intercepts. There's an x-intercept there, and it rides on the, it's like a perpetual x-intercept there and there. And it crosses right there. So we can read v and t. The gradient is delta v over delta t, which is the acceleration. The area is delta v times delta t, which is the displacement, delta x. So we've interpreted that. So now we have an experiment with a cart that travels across a horizontal surface and collides with a wall. All right, so we notice the velocity starts out 0. And so the velocity starting out at 0, it then increases and travels at a fairly constant velocity up to point A. But the velocity when it occurs is positive. So if this is our positive direction and this is the negative direction, then we have some cart like this moving in the positive direction. There is our wall. And so initially it's going to be moving like this. And once it's set in motion from rest, so we've got a v0 equal to 0, and it eventually speeds up, it accelerates. Oh, and that's the slope. And we can see that, that acceleration there, it accelerates, it changed from one velocity to another, and then it remains constant. So v is constant, and that occurs, we might see then at about, 1.4 seconds or about 1.3 seconds. So the first 1.3 seconds, the first 1 second, it's at rest, and then it accelerates, and then it's at constant velocity. All right, so it's going to move to the right and hit the wall. So that's just making sense of it again. So data collected from the experiment used to create the graph of the velocity time, we've got that. All frictional forces are considered to be negligible. Good. So no friction. When data from the graphs to determine the direction of the net force exerted on the cart. The direction of the net force exerted on the cart and the direction of the change in momentum. So when we're talking about momentum, we have our four-way equivalence. Impulse equals F delta T equals delta P equals M delta V. So we've got F net delta T delta P. So the question is looking at this. All right, so we know with the F net, we're trying to find what the direction is. Is it positive? Is it positive or is it negative? And the change in momentum, is it positive or negative? We know then we might look at the mass and the change in velocity. Is it positive or negative? And so what we see in the beginning, the delta V is V minus V0. Afterward, after the collision, during the time interval A to B, that's when it's hitting the wall. Let me make that orange, excuse me. So that's where, again, we have acceleration. Now, the acceleration we can see is negative. The acceleration is negative. Over on the other side, the acceleration was positive. We have negative acceleration from A to B. And delta V, which we have a final velocity of minus 0.4. And V0 was positive 0.4. So minus 0.4 minus 0.4 is minus 0.8. So the change in velocity is negative. Now, the acceleration, we said, was also negative. So we're going to divide that by a delta t. And so acceleration, delta v over delta t, is going to be negative. And we also know then that F net delta t, which is m delta v, we know that delta v is going to be negative, and so therefore the force must be negative. And if the delta v is negative, the change in momentum will be negative. Well, we could think about that more simply. The fact of the matter is, afterward, the cart is moving in this direction. So beforehand, the momentum was positive, and afterward, the momentum is negative. So the change is negative, and if we think about this from just a pure force perspective, the force of the wall on the cart must also be negative. So for a whole bunch of lines of argument, from the change in velocity being negative, to the acceleration being negative, to the change in momentum being negative, we know that the force must also be negative. So what information would we need? Slope of the line from A to B, because that will provide acceleration of the cart. And that's true. That actually seems to be true. F net is ma. And that comes from rearranging our equation. If F net delta t is m delta v, well, if we divide both sides by delta t, we have F net equals ma. So if the acceleration is negative, the force will be negative, and vice versa. So that looks like that's our answer. But let's go ahead. The area is the displacement, delta x. Well, the displacement is not going to tell us the force, direction of the force. The difference in speed. Well, speed is the absolute value of velocity. In both cases, the speed is 0.4. So 0.4 minus 0.4 is 0. The difference in speed is 0. That's not going to tell us the force. The graph cannot be used to make the determination because the mass must be known. And that, of course, is false. We've shown that in a number of ways. And that's why the answer is choice A.